particle P moves in a straight line such that its displacement x meters from a fixed point O at time t seconds is given by x is equal to 2 plus 3t minus 2t cubed. We want to find the following things. The first one is the distance of P from O when t is 0. Substituting t is 0 into our expression for x, we can see that this term and this term will both be 0, so that's going to be 2 meters. The distance of P from O when t is 2, so now what we want to do is calculate x of 2. So that's going to be 2, add 3 times 2, take away 2 times 2 cubed, so that's 2 plus 6, take away 16, which is negative 8 meters. Now that's a displacement. Distance can't have a negative, so our distance would be 8 meters. The negative just indicates it's on the left of the origin, whereas this positive 2 means to the right of the origin. Now in part C we want the initial velocity of P, so initial means at the beginning, therefore t is 0, and to go from displacement to velocity we differentiate. So the 2 disappears and then we're going to get 3, take away 6t squared. So v of 0 is equal to 3 meters per second. Now in part D we want the acceleration when t is 1. So to get to acceleration we differentiate velocity, so that would be negative 12t. So a of 1 is negative 12 meters per second squared. Now in this case the negative is important here because acceleration is a vector. If this is O and this is the line the particle is moving on, so this is the origin just here, then you have positive displacement on this side and negative on this side, just as you would with a number line. If it's moving this way, the velocity is positive, and if it's moving this way, the velocity is negative. Acceleration to the right is positive, acceleration to the left is negative. So if we look at part C, that's a positive 3 telling me that it's travelling this way at 3 meters per second, but a negative acceleration when t is 1 tells me that the acceleration is to the left.